Alright, so let me go ahead and give you that answer key. And we can talk about whatever you want to focus on.
I brought my graph paper. No joy. It's just that like I'm so mad
Oh yeah.
I got you back.
Alright guys, so just like before, I highly recommend that if you have not tried to practice steps out yet, you don't just look at the answer key. In fact, there's a couple on there that we have to finish. I think I was looking for a calculator and I forgot to come back to it. So we'll do, I think it's number, just noticing number 3, B, and C. Blah, blah, blah. Just being lazy. Number 9, I kind of put all of them there, so if you want to see something up on the board, there's one problem where you have to be careful about the shape. It's a weird shape. One of the practice problems I gave you. Let's see what else I got going on here. Yeah, so let's first look at 3B and 3C, since I didn't finish those out.
I
Somebody else feel like it really isn't the end of the semester? Or I don't know, has it seemed like forever for you? Or does it seem like yesterday we started? It feels like yesterday we started. It's weird. 3B. So I've noticed a few of you guys like that proportion method, and that's perfectly fine. There's nothing wrong with that. I think more of us do the equation method, which is obviously also perfectly fine. The equation method here would be 72 equals what percent? Good, X of, yeah. So this is where I got a little lazy. The next step is to do 180. You divide it in, and then you just divide those. I really didn't feel like doing that long division. But if you do divide those, can somebody help me out? What do you get when you divide those?
40%. 40%.
Oh, really? Goes in nice. Let's see. 40%, sweet. So it goes in is 0.4?
1.4.
What is it?
0.4.
0.4.
Or if you just divide it, it's 0.4.
Oh, just 0.4, okay,
0.4,
gotcha.
yeah.
Which translates into 40%, sweet. Okay, cool. Be real careful. A few of us are still doing this. You get 0.4 as an answer, and then you just slap a percentage on there. It's a decimal when the math deals with it, and then you got to convert it into a percentage. So don't do that. Don't just slap a percentage symbol on there. You have to move that decimal over. And then 3C, I think I just forgot to come back to it. Same way, 2 is 5% of what? So you send that up the same way. 2.
Can you do it the other way?
Oh, sure. So if you do it the other way, is over of, percent over 100. So obviously what goes up here? The 5. The is
Is it 2?
2. 2 is. Of what?
X.
I don't know. Cool. And then you can cross multiply and go from there.
Can you do it the other way?
Sure. So 200, I'll do this real quick.
I love this method.
You'll be all right. I didn't really plan that, by the way. It just happened. The other way would be 2 is 5%, 0.05, good. Of what? I don't know.
That rejects me.
And then divide by 0.05. And real quick, just to show you these are the same, if I move this over once, twice to make it 5, I'm going to move the top over once, twice So it's 200 over 5, which is exactly what that way gets us to, right? Either way you want to do it is perfectly fine.
So when you change percent, it goes, is it zeros going in the back of it?
So when you have a percent and you want to make it into a decimal, it will always get smaller. The percent number is always bigger than the decimal number. Right? Do you see how 5%? Want to make it into a decimal, it's really small, 0.05. It's got to move back once, twice. If I have a decimal and I want to make it a percentage, it's got to move forward twice. It's got to get bigger. So you can always remember the percent number is bigger than the decimal number. It's a quick way to kind of remember, check at the end, did you move it the right way? So is there anything specific or general related to mathematics that you guys want to do? Yeah. Second? Yeah.
I forgot, it says 3/5 over 60 over 100. I forgot how you change that.
Oh, so when you have a fraction and you want to make it up. So the very first entry in that number 1 starts off as 3/5. To make that into a percent, or even to make it into a decimal easier, if I can make the bottom 10 or 100, then it would become a percent easier if it was 100, right? And then a decimal would be pretty simple too, because decimals are just out of 10, 100. So how do I make the bottom become 100?
Times 2.
Times
2 times 5.
20. Oh, cool. Get that extra 0 there, so times 20, 60 out of 100. And then what is that as a percent then? 60%. Good, because percent means per 100. It just takes the place of that over 100. So that'd be 60%. As a decimal, 0.6. Either it's 60 over 100, which is 0.60, or you move that decimal back once, twice, so it's either way you do it, it ends up to be 0.6. You look less than satisfied, Jeremy. What's up?
I can't read, I can't see it.
I am kind of writing small, you're right.
There's seats on the front.
Cool. And then that becomes directly a percentage. Cool.
They have, mine does one part, 1%, I do that in decimal.
Oh yeah, that was on the quiz, right?
Yeah.
So if I had, for example, 87.2%, just to do one like that, how do I make that into a decimal? What do you do?
You move it to the left.
Yeah, why? No, I don't like that. You don't do anything just because I told you to. Anything I say, you should be like, really? Is that right? That's the way it should be. Percent means per 100, right? Dividing by 100. So if I actually, instead of just writing a symbol that means divide by 100, if I actually divide by 100, this is going to get smaller, isn't it? So that should make sense. The percent number will always be bigger than the decimal number will be. Because the decimal is after I actually divide by 100. Percentage is, I'm not going to divide by 100 yet. I don't want to. So when you make this into a decimal, you got to move this sucker back once, twice. So if I had something like 0.6%, this is where people mess up. They think to themselves, it's already small, I don't want to be mean to it, make it even smaller, screw it. It's a percentage. When it wants to become a decimal, it's got to become smaller. It's got to go once, twice, 0.006. So the process does not care what the number is. The process does not change.
So when you want to write it in a fraction, when it's that small, it would be over the hundreds.
Well, if I want to make this, it would be tenths, hundredths, thousandths. And it should make sense. If it was 6 over 100, wouldn't that be 6%? But it wasn't 6%, it was 0.6%, so it should be even smaller. So it's not 6 over 100, it actually comes out to be 6 over 1,000 to make it smaller.
So it was like 0.013.
0.013%? Or just 0.013?
No, as a decimal, 0.013, right? And then from there, if you, it would be 13 over 1,000 for the fraction, and then for the percent, it would be 1.3.
Could be, yeah. Because you always move this sucker
Right.
twice. Alright. Just gave me the answer key. Oh yeah, you need your.
It's really hot.
Oh, you need. So guys, just to make this clear, you can make corrections to this last quiz that you just got back. You can make corrections to the next, the next test. Right, so that, we're gonna have a test on Tuesday. Then I give it back to you on Thursday. That's the day of review for the final. And then those corrections will be due by the day of the final. So you can correct everything in here except the final. It's appropriately named. Oh, that's just so you saw what it looked like.
What if you missed that quiz?
Then the next test grade will also count for the quiz grade. So effectively, the next test is just going to count a little more.
So they're really good at the next test.
Olivia, you?
So would you take my?
I thought you said good. Oh.
Yeah.
So you guys, yeah.
I have no math reports.
Practice test, 360.
I looked at my plans and everything.
Fractions, algebra,
Three.
How about for your like prereqs? 'Cause that's the thing.
Like prereqs one take, but my.
Oh,
Like,
3 over
math-
16, yeah.
Like math 110 might be one of our prereqs.
My prereqs covered by so I have to apply.
All right, guys. If I had to convert
'Cause like for us, we have to take
3 over 16. Now we did the 3/5, and that was nice to make it into a decimal or a percent because the bottom becomes 10 or 100. That's beautiful. So that was nice. All right, 3 over 16. No, that's so nice. Right, because the bottom can't easily become 100. What do you multiply 16 by to make 100? Something. I don't know. 6 point something. Somebody's looking it up.
6.25.
All right. So, how do you do this then? Now the funky thing is,
Not so nice.
what he just did, there's actually a shortcut to use that, but I'm not going to show. I'll show you that if you're interested in it. Because you just did 16 that goes into 100 6.25 times.
Yeah, it's just divided 100 by 16.
Exactly. You can actually use that to make what we're going to do, a shortcut into it. So I'll tell you about it if you want to ask me. If not, this is what you do, the standard thing you do. You have to do the long division. So on the test, I'm not going to do this a lot, but I will have a couple that will say, I want to see your work. Guys, I will have a couple that I'll say, I want to see your work. But most of them will be, you can use a calculator for it. Because we'll be curious about more than just, are you able to do the long division? We're a little bit past that. But I will have a couple where I'll say, show me the division. I don't really feel like doing it right now. That's how you do it. And once you get it into a decimal, how do you make it into a percentage? Just move the decimal place over. Right? So when you do this division, I actually did it. I'm not going to do it again because I already did it on the answer key. I forgot I did that. So you get 0.1875, hopefully. And then when you make that into, so how do you make that into a percentage?
Move the decimal
Move the
twice.
decimal twice.
Yeah,
Right.
once, twice.
Yay.
So again, let me say this one more time, because this is the easiest thing to memorize. The percentage number will always be bigger than the decimal number. Right? If you just remember that, that tells you which direction to move the decimal. You don't have to remember left and right. You just remember that one thing. Percentage number, always bigger than decimal number. Always. Okay. I hate to memorize a lot. I want to memorize less. Okay?
Oh, like where you have you write out the D and then the P and then that way you know which way to go.
Oh yeah. I don't know, I try that, but it seems to not get the most love. But if you put it in alphabetical order,
Yeah, it makes
from
sense.
decimal to percent, you move it that way. From percent to decimal, you move it back.
Yeah.
To me, that makes beautiful sense, but people don't seem to use it very much, so I don't know. If you like that, I love it. Kicks ass. Personally, I've done this so damn much, it's just automatic. It's sort of like I know what the word tree means, because I've used it forever. It's just automatic to me. It would be almost like grading my nails on a chalkboard. It could make it go the wrong way just because it's so ingrained in my brain. But as we're trying to ingrain it in our brain, this is not a bad little device to use. From decimal to percent, you move it that way like we just did. Decimal, move it that way to get to percent. From percent, I would move it back to get to decimal. Okay, cool. Yeah.
How do you go from there to fraction?
Just started off as a fraction.
What if there's no fraction, you have to take decimal?
So now I've got 0.1875. What would that be as a fraction? What place is that in?
1,000.
Tenths, hundredths, thousands,
Oh.
10,000s. So 1875
Over 10,000.
over 10,000. And believe it or not, that would reduce to 3 over 16. Obviously. I'm not super concerned with you reducing the fractions you get from these. In fact, if you only show me the reduced part, like I said before, I'm going to have to assume that came out of the calculator because several of our calculators have fraction buttons. Unfortunately, they give it to you in reduced form only. So if you only have the reduced form on there, I'm going to take off quite a few points because that's your calculator doing the work is what I'm going to have to assume. So show me this. You don't even have to reduce it is what I just said. If you want to, great, but show me this at least. Okay. Yeah.
We can use calculator, you know?
Like I said, there'll be a couple that I say, show me the work. Of course. Because that is what that is. Yeah. Yeah. But there will be a few. You gotta continue to reinforce the skills, yeah. But you can use your calculator to check yourself, nothing wrong with that.
It's very easy, yeah?
Huh?
By calculator, it's very easy.
That's amazing.
Maybe mistake when I do.
That's the point. Of course. I love that fruit. Of course it's easy on the calculator, because something else is doing the work. So here, just to reinforce that off, I'm not gonna ask you to do every problem by hand, but I will ask you a couple to show me the work.
My
Because
calculator thinks it's a
when
genius.
we work, when your hand.
What's that?
My calculator thinks it's a genius.
For the most part, it is.
No. He's trying to upstage me.
Is there, anything else you wanna kind of focus on? Yeah.
How can I tell whether the fraction I'm supposed to put is this or this?
If I don't give you the fraction, then you can put it, just like here, Jim. If I give you just this, you can give me just this. You don't have to reduce it. You could, you don't have to. Why did I put this? Because it's tenths, hundreds, thousands, 10,000s. I know what place it's in. So we cannot forget our old stuff. Just because we go to a new section doesn't mean everything we've learned before I'm not going to use. We know that's not how math works. Everything you learned before will suddenly come up again. And then whatever new stuff you learn will also come up again, forever and ever. Builds.
It's one of those days.
So what would that be as a fraction right there?
0.317.
As a fraction.
Oh, as a fraction. Oh, that'd be.
Yeah, tenths, hundredths, thousandths,
It'd be 100.
10,000ths, 100,000. Yes, so it'd be 317. What would that be as a percent?
0.317.
I like it. Once, twice, 0.317. Why did I do that? Percent. I love it. Percent number always bigger than decimal number. So real quick check you can make at the end to make sure you went the right way. Okay. I had trouble because I still to this day have trouble with left and right. So a lot of what we learn in math, believe it or not, a lot of decimal movement is all about left and right. So I start to memorize things as big and small. Percent bigger than decimal, that totally helps me. You say left and right, like shit, which way is left? Give me a break, right? I'm good with math, I gotta be bad at something else. Bad at cards.
You do.
Huh?
Did you say cards or
Cards.
Oh, I thought you said
I know
cards.
the statistics and all that crap, but the poker face, no. So anything else we wanna focus on?
You get like 3 1/4.
Oh, there was, do you remember where it was? If I started off with, I think there's a couple in the homework like this. If I had 3 1/4%, that's probably one of the ugliest problems you can start with. And the problem with this is I want to take it to a decimal and to a true fraction. And some people might argue, well, it's already a fraction. No, it's not. It's a percentage. It's a percentage that has a fraction in it, but it's not truly a fraction. Kind of with me? Because what's percent mean? Over 100. And I haven't shown that here. I haven't made it fully into just one fraction. It's a fraction with another piece to it. I haven't put those together yet. So the easiest way to handle this is to first write 1/4 as the decimal part instead of the fractional part. So what is 1/4? Yeah, make this 3.25%.
I have a question. Could you put it just, what is it, 13/4%?
Sure, you could make it 12, you could make it 13/4%,
And then, I don't know, okay, proceed.
and then that would be actually a little bit disgusting. Then you have to divide it in to get there, but it was easier to get there just straight.
Okay, you can
Yeah.
just erase that.
So you could do that, I wouldn't say you should.
Okay.
Now, so here's the percent, what would that be as a decimal? I like it. Percent always bigger than the decimal, so I gotta make this smaller, 0.0325. And then how do I make that into a fraction? Yeah, 325 over tenths, hundreds, thousands, 10,000ths. I love it. Sweet. It should be a small fraction. Should be a small fraction. Because it was such a small percentage to begin with. There's only 3 1/4%. That's kind of small. Should be kind of a small fraction. Only 325 out of 10,000. That's pretty small.
You don't have any corrections for 3C.
We did that earlier. Yeah.
Ah,
Did that first thing.
It's your birthday.
well, I'm sorry to recap.
What'd you get?
I would wear that.
2 is 5% of what? And then you divide by 0.05.
I'm doing that on the quiz here since it's, yeah, after the quiz.
Let's say it's my birthday.
You got a little.
I still got it for me. I didn't.
Oh, okay, yeah.
The thing is, when I divide by 13, I got this.
Yeah, be careful. It's not 13, it's 13%. So what's 13% become? 0.13. You gotta divide by 0.13. How are your other classes going?
Annoying.
Just to change
Do you know who's
subject.
Pipkin?
Huh?
Do you know Nancy Pipkin?
Yes.
I don't like her. She talks a lot.
She's funny. What I can imagine as a student in her class.
Do you know what her system is? I feel like it's a bit.
I was thinking we go over like the number 8 on the practice set, which is like the plotting stuff. Make a table of values.
Oh, yeah.
And then the graph.
That's what I was expecting some questions about, yeah. So you make me feel a little better.
Bam, expectations fulfilled.
Alright, let's not do that one exactly, because I already did that one. Let's do another one. Alright. So if I ask you to make a table of values for this and then graph, what do I mean when I say table of values? What do you set up?
The X and the Y.
Good, so like an XY table is the other way to say that. Now, this is not always true. This is the way we teach it to begin with, just to get the basics down. But X doesn't necessarily have to be the thing we pick. Y in this case is it because Y equals some mess with X. So of course I want to pick X first. And then I could figure out what Y is. But if it was X equals something Y, I would pick Y first and then figure out what X is. It doesn't really matter. So I want to make sure you understand. We do this way just to get us into the idea. But it doesn't even have to be X and Y. It could be R and T. For like revenue and time or something. Right? Just depending on the whatever the word problem's about. So what can I pick for X? What's a good
7.2.
1.
Neato, I could.
Uh,
Let's not.
Okay.
1.
So we picked 0 is not a bad idea. And then 1.
0.
So if you put a 0 in, what do you get for Y?
9.
So if I put a 0 in for X, exactly, I get a 9 out. You guys with me? For some reason, I get some people that do this, and they do this. And what happened there?
They forgot to multiply.
Yeah, times 0, that's dead. Let it die. Let it go away. So when you plug a 0 in, that should be the easiest example, because your variable, your X just dies. And then what's the answer? Whatever the other thing is. And what about when you plug a 1 in?
It's gonna make it 5.
Good. Now that'll be 5, like they try to do there. That's not right. So that's 5. And what about, let's just keep going. What about 2?
What?
Careful.
What?
1. Yeah, negative 8 plus 9. What?
Oh, never mind.
You guys still with me?
Might be negative.
It doesn't, to a certain degree. You could, technically you could use a million. I don't want to, but it doesn't really matter as long as it's something that's easy for you to graph. So if I plug in 0 and my answer is 28, I might not even use that point. And if I plug in 3 and my answer is 5, okay, that's easier to graph. I'm going to use that. So we really could just use points that are easy to graph, because the next thing we do is we connect it and we say it goes on forever. So we do end up getting all the points. So who cares what we use to graph it? I just need a couple to anchor my line.
So it'll always, like, no matter what numbers you pick.
Exactly. So if I picked 100, I'm not going to graph this, but this will be negative 4 times 100 plus 9. Negative 400 plus 9 is negative 391. So the line I'm going to plot, I'm only going to show so much of it, but then I'm going to put little arrows on it. So if somebody says, you didn't get the answer I want, you just tell them, just keep going. You'll get to whatever the hell you want, leave me alone. Right. I want to point this out. Every time X went up by 1, you see from 0 it went to 1 to 2, right? What did the Y do?
It goes down.
Down by how much?
4.
Careful. Yeah, it went down by 4, down by 4, down by 4. So if I would have put a negative 3 there, it would have went down by 3, down by this. Very interesting. So some guys might realize I'm trying to prep you for when you talk about slope in the next class. That's really all it is. How much does X change, and how much does that affect Y? That's controlled by that number right there. It's kind of neat. Okay.
Is that starting from the starting point? Is that?
Yeah, starting from any point. If my X changes by 1, my Y will change by this much. Kinda neat, see how it changed by 4 down, 4 down?
Really, checking the gap of that axis.
Yeah, how much, if I change on this one, how much does it change on that one? Perfect. So if I go to graph this, let's do, let me show you something, 2, 4, 6, 8, 10. So I don't have any negatives really. All right, so when I go to plot this, 0, 9, and let me make this point. Your scale does not always have to be 1, 2, 3, but it does have to be consistent. So if I were to make a scale like this, and I've seen this, why is that not a good scale?
So many variables.
Yeah, this is 3, 3, but this is 1, 2. It's got to be consistent. Every single time you go by the same amount, it should change by the same amount. That would only make it fair. That would be somebody trying to skew the data to make it look different, right? We lost a little money. Let me change the scale so it doesn't look so bad.
Sending a subliminal message.
Yeah, so no good. So here, 0, 9, where would that be? Where would I go to get to 0? It's pretty cool. That's the point there, right? 0, 9. What point's here? 1, 5.
2, 1.
2, 1. 100. Negative 391. 11. So we're probably not going to plot that last one. Let's not do that. So 0, 9, where is that? Good. You don't go left and right at all. You just go up 9. The first thing tells you on the x-axis, where do you go? So I don't go on the x-axis at all. The second thing tells me on the y-axis, where do I go? 9. What about this guy?
So if you had a negative, you would go down.
Or back? 11.
Back, yeah.
So 1, 5, so I move
To the right.
over 5, over 1, sorry, and then up
5.
5.
2, 1.
2, 1.
2 from
So over
2.
2,
Up 1.
up 1,
Up 1.
and so forth, forever. So then here's my line. So can you imagine once I get out to 100, x is 100, this sucker's going down pretty fast, so it's going to make it all the way down to negative 391. So you just tell somebody, if you don't want any of this, just keep going this way. But don't forget, one reason we do this is because it's the quickest way to answer what are the answers to this. Because how many answers are there to this? Infinite number, holy crap, I don't want to list them. I'd rather just say here. It's a quick visual of that answers. Right? That's the best way to answer that question. Okay. How do you feel about that? Do you want to do another one, or do you want to do something different? Yeah, do another one. Do something different. Let's do one more graphing, and then we'll do whatever else you want to do. Give me one that's a little different format. So on one like this, I might lead you a little bit. So what I mean by that is I might give you a table like this. Not like that, Jeff. So I might give you some things to try. So here's what I was talking about earlier. X does not always have to be the input. Either one really could be the input. So try to do this problem. Try to finish this table out. And one other way to look at this is just like the problems you were doing way back at the beginning of this class. I give you an expression and then I tell you what these are. You just plug in the values one at a time and do it. So if x is 0, What's y? Figure it out.
Dy percent.
That'd be 2.
Yeah, because when you plug in a 0 for x,
Dy percent.
this goes away. So you get 3y equals 6. Divided by 3y is 2. Cool. Uh-oh. Alright, we'll do that again. So again, that problem was actually a little bit harder because I left the table blank. You have to pick your own stuff to throw in, but then it's kind of free. You can pick whatever the hell you want to. Here, I'm telling you, if x is 0, what's the corresponding y? So you throw in x is 0. Right? Twice x, but what's x? 0. So for this first one, x is 0. And then you just solve it. That's a nice little equation now. Just solve it. Twice 0 is 0. Right? Twice 0 is 0. It's gone. So you get 3y equals 6. How do I solve that? You divide by 3. So then y must be 2. So now you do the same thing for number 2. What do I tell you in number 2?
2 times 3.
Yeah, I tell you that x is 3. So for that one, you just plug in a 3. And then solve that. That's all. So we've done problems like a plus b minus c, and then I tell you, what if a is 4, b is -5, and c is -6? You just plug them in, right? You just plug them in and figure out what it is. That's pretty much almost exactly what we're doing here. But you see how I was doing the same thing? X is 0, so I plugged a 0 in. It's the same thing. X is 1, so I plugged a 1 in. And then I figured out what it was. We're doing the same thing. Plug a 0 in. Figure out what the other one is. Plug a 3 in. What's going to happen here?
It's gotta be there.
6 plus 3y equals 6. So y is 0. Alright, so you guys either seem bored with this, which is good in a way, because that means it's easy, or you seem, well, I'm just not going to do that problem straight. I can't completely tell where everybody lies, but I think some of you are in both. So all that's going on here is I've got this set up for me, that equation. All I need to do is figure out what pairs of numbers make this work. Guys, so I'm trying to figure out pairs of numbers that make it work. So one kind of problem you saw in the homework was, is this an answer to this? How do you check if this is an answer to this? Plug it in. I know x is 1, y is -1, so if you plug in 1 and -1, is that true? 2 minus 3, is that 6? No. So this is not a solution. So what that means is the graph of this would not go through this point, because that point is not an answer to this. The graph of this will only go through the points that work. Yes, sir?
So as an answer, can you just put false?
Better just say not a solution.
Okay.
Yeah. All right. So what does that have to do with what we're doing? Well, if I need to find two numbers that work, let me pick one number and then see which other number has to go with that to make it work. So if I have 0 for x, what does y have to be to make this true? It can't be anything. It's got to be, it turns out it's got to be 2. That's the only thing that'll make this come out to equal 6. So if I make x 0, y must be 2 to make this true. If I make x 3, y must be 0 to make this true. If I make y -2, what must be true? Let's solve it and see. If I make one of them a certain number, what must the other one be to make this true? Well, how do I get that? I just solve for it. I solve for what x must be to make this true. So anytime we solve an equation, we're trying to figure out what does that letter have to be to make this thing true. So if I do solve this, 3 times negative 2.
-6. So then you plus 6.
Good, add 6.
Makes it 12.
2x equals 12.
6.
X equals 6. Cool. So you've seen both kind of problems in the homework. You saw the ones that they don't give you anything in the table, and you saw the ones that they give you a few things in the table. You gotta plug it in and see what it is. So now that we have this, what points can I plot?
0, 2, 3, 0, and 6. -2.
Yep, so the points would be 0, 2, 3, 0,
6.
6, -2. And a point really does mean those things go together. When x is 0, y must be 2 to fit on this. When x is 3, y must be 0 to fit on this. So that's why they must stay together. That's why they're two parts of one thing. Oh, that's not good. Okay. So where's 0, 2 at? Good. So you don't go anywhere this way, you go up 2. That scale sucks big time, but oh. What about this point? 3, 0. Yeah, I only go right 3, up and down, I don't go at all, right? Over 3, not up or down at all, so I end up right on 3 there. Good. What about 6, -2? Over 6
And down.
and down 2, I love it. So it's kind of cool when you do these and you see that, especially if your scale's good, that the points actually do line up.
I can see that, but the other.
Sorry.
That was random. It's the tape of a live audience.
That's when I send an email.
All right, so how's that feel for everybody? Yeah.
I have a question on something else.
Yeah, sure.
Where you gave us that graphing worksheet, and it says like graph x3. Is that when you just do the line?
Oh yeah.
That's pretty much it.
So
The end of it.
the two special cases were like x equal to 3.
Right.
And that seems really like, okay, there's not much to go on there. But no matter what y you pick, x is 3. That's the definition of this, right? So if y is 0, x is 3. If y is 1, x is 3. So you end up with this line here. So think about it. If x controls left and right, and x has to be 3, it can't move left or right. X can't change. So it's got to be a straight up and down line. Every single point on this line, x will be 3. Right? So it does match this definition. Just like every single point on this line does what? Twice the x part plus 3 times the y part is 6. That's what they do. So every point on this line must do this. What does y have to do? Nothing. It can do whatever the hell it wants to. Let's go crazy. So what would this line look like? What would that line look like?
Move over what? -1.
So y must be -1, so it can't go up or down. Because if y changes, that would go up or down. So it's got to be a line like this, at -1. So if x is 0, y is -1. If x is 1, y is -1. So forth. Those are two special cases. And they should kind of strike you as special, because both of them don't have the other letter. A normal line looks like this. That'd be a normal line. These are special because each one is missing the other variable. It should be kind of, it's not hard, it's just different. That's pretty damn easy. I didn't have to do any work. You just gotta remember what it means. X equals straight up and down, Y equals straight across, horizontal. Just two special cases. Cool.
Your shoes untied.
I know. It happens. Yeah.
Can we do the one that says graph y equals x squared minus 4?
Sure.
I have a question too, really quickly before you do that.
Okay.
On the quiz, when I did my answer, I told you it was all right, except I didn't write the total amount of students.
Okay.
You just add the 2 up. Can I when I do my corrections, do I have to redo it all, or?
No, just do the last step. Yeah. What was it?
It was y equals x squared minus 4.
So guys, real quick, we can extend this idea. Now, this is actually going a little bit beyond what we really have to do in this class. But I thought it made sense. Because I don't care what function I put there. I don't care if it's y equals a square root, y equals an absolute value, y equals who knows what, all these functions we haven't even learned yet. I can always start with the XY table. Always. And in fact, even in pre-calculus this semester, with my math 176 students, we were making XY tables to investigate functions that we were just learning. So when you get a brand new function, the first thing you want to do is make an XY table, look what the hell it looks like. Right? Humans like visualizations. So I do the same exact thing. Guys, if you're ready for the test, you don't have to be here. You can head out. I'm not keeping you here. It's college. So if you're ready for that test, you can go ahead and head out. So how do I make an XY table? What do I do first?
You'd have to figure out what x and y are.
But the nice thing is, you get to pick what one of them is. Yeah. So for example, if I make x 0, that's a good place to start. What would happen then? If x is 0? Yeah, y is negative 4. You guys kind of with me?
Yeah.
And especially when it's a function you're not sure about, you want to put some positives, some negatives, just to see what it does.
Okay.
So if I put in there 1, what's it going to do? Negative 3. What if I put in there negative 1? Hold on.
It's going to be negative 2.
It's the same because negative 1 squared is 1, just like 1 squared is 1. So again, I get negative 3. And just to finish this out real quick, if I put 2 and negative 2, so if I put 2 in there, I get 0. And if I put negative 2 in there, you know, Jeff, again I get 4 minus 4, again I get 0. So when I plot those points, I'm doing this kind of quickly because it's not something you're going to see unless it's a bonus. I plot them the same way. 0, negative 4, 1, negative 3, and negative 1, negative 3. And then 2, 0, negative 2, 0. It turns out to be this.
Yeah, the curve thing.
The curve thing.
What's that called?
Parabola.
What?
Parabola. Parabola.
Parabola.
Yeah.
Parabolas.
So you have all kinds of bolas.
Yeah, I know it's Spanish.
Hyperbola, parabola. Thankfully, no Ebola. So anytime you have a function, anytime you have an equation you're working with where the variable has a power that's not 1, you're going to get some kind of curve to it. So if I had an 8th power there, I could have a function that looks like this. Wee-haw, wee-haw, and somewhere it goes up forever. It's got all these turns in the middle. Right? We're just dealing with linear functions in here, really, with lines. They're just going to come out straight line. It's the first degree, first power. The power on the x is 1, like that y equal x minus 4 or whatever. Here it's squared, so it's going to come out curved somehow. Cool.
Okay, so in that case, you just plug in whatever number you want. You don't have to try to figure it out with the formula.
Same thing we do with y. We pick a number for x or y, and we solve for the other guy. You always do the same thing. So even if I gave you a function that the cube root of x minus 5 plus the absolute value of x plus 2. Oh my god, it's gross. It would just be a bunch of plug and shove problems. Put a 0 in, figure it out. Put a 1 in, figure it out. Same thing, even though it's disgusting as hell, we actually come back and do the same thing. We just plug points in, see what the other part is. Cool. That's really the only reason I put that on there, is just to show you it's not that big of a step to keep going for more advanced problems. I do this a lot. I do this a lot. One of the classmates funny me, I'm like, maybe all the time. They have poker face. I don't want to play poker with a lot of my students. Do you understand? Give me something. Be like, yeah, totally. What the hell's it? So anything else we want to focus on? Oh, so in a test, I'll tell you. Here, you can just go out a couple places. So, how'd you get there? Oh, it won't be a percent. I'm not asking for a percent. I'm asking for what number. I know the percentage already is 13. I want to know what number is 13% of 20. What number, yeah. So it's not a percentage answer. So it's not 13 over 28. It's again, if you want to go straight to math, translate it. What number? What do we use in math to represent something I don't know? Good. Is equals 11. 13%. What 1 to 3 of means multiply. So all I'm really going to do is multiply those.
No, sure.
And then you'll be done. You just do that 0.13 times 28. The only mistake you made was not going back far enough. So you didn't move your decimal back far enough, and it's not a percentage thing. That's the only mistake. You got the right numbers, you just didn't have the right decimal place. So again, those quiz corrections are due Tuesday. Yep. And then the tests will get back next Thursday. That'll be due the day of the final if you want to do corrections or if you have to. Everybody got a practice test? That's an answer key? Everybody got an answer key? No? Answer? You need a blank one or not? A blank one. A blank one.
No, I have one. Actually, I'm good, Jeff. I'm good.
You got it?
I'm good,
Oh.
Jeff. Thank you.
It was getting close. It was 138. Yeah. 9%. What? What? What do we use in algebra?
I already started with 22.
So whenever you see that, what? Math is going to look at it as that's what it's going to put at the top. So now I know it. Now I look at this and say, oh, I just divide by 0.96. And that would mean that, yeah. I'll tell you what. If you two ways you can do this. Given enough test.
Oh, yeah.
Monday. Given a test. I got one. Given a test on Monday and my stats. I'll tell you what, if you email me I teach Mondays and Wednesdays, 9 to 10:15. Would that work? Oh, and I teach Wednesdays, 12:30 to 3:20. Yeah, so I just gotta remember, I can't remember at the moment which day I'm doing the pre-calc test. I think it's Monday. So on Monday afternoon. Okay, good. So, let me tell you, so it's at 12:30. Yeah, good. I'm not. Yeah. Normally when a full-timer picks their schedule, they keep the same one for fall to spring. I'm teaching another 88 and 160 and 176. Yeah. Yeah. But I mean, we could look at, who's teaching the 90s and get some examples. Oh, you got some? Alright, who do you get for 90?
You ain't taking 90, I mean, you ain't teaching 90, are you? Yeah, pretty easy.
Sorry, guys.
I heard that if you go 103 or 110, it's in the direction.
It is, and we'll talk about it, we can talk about it again, because at one point I think we'll talk about it again a little bit. 103 only leads to 120 and 160. So it's if you're really sure you don't need a lot of math for your major, that's the way to go. If there's any chance at all that you need more math for your major, you wanna take 110. Because a lot of people take the 103, and then they go change their major, and then they gotta also take 110, it's a big waste of time.
So when I'm at 88 now, well, I either take the 90 and then what?
Yeah, you can take the 90, and then you can take the 103 or the 110. After that.
From 90 to 110?
You could, that's the way it's set. Oh, I'm sorry, real quick, Wednesday, 12:30? Or Monday? Monday. 12:30. In 55, that's the one that's over there by the parking
Like
garage.
right now?
That building.
Cause I usually do like 138.
It's Plattsburgh. 12:30. They got 3 hours, so I'll shop after a couple hours, and then I won't be done.
That was good. Thank you, I appreciate it.
No problem.
I did, I made this point.
Oh, no.
I think you turned it the wrong way. It's 138 divided by 1. You might have put it in there.
Oh, yeah, okay.
Oh, yeah, thank you.
We already have the
Wait. Oh, so the only mistake you made here was, again, you didn't push it back far. So if you push it all the way back here, it's 7 more students. So if I had 140, I got 7 more, and now I've got 147. You weren't completely wrong, you just put the decimal and ended up being wrong.
Permanent.
Yes, oh yeah. That's what we did, reviewed it today.
Good, everything good?
Yeah.
Off the top of my head, I can't remember now. It's 7, 8, 9. Chapter 7, 8, and 9. Yeah. Got one section down to 9 with the area and the volume.
Oh, no, that's why.
So when you look at 23 over 100, that's the way we normally say it. But the quicker way to say it, I can't say 2300 because that would be 2300 like that. So the way what we decided to do is 2300. That's just all it is. So what place is the hundred?
Yeah, the homework sheet is in this.
Careful. This is 10, 100, exactly. Exactly. So I don't need those
You
ones.
have to
So to do 2300s, I want to make sure that the last digit ends up in the hundreds place. So there's 2300s. Good.
Here we go. See it over here, it says,
So it'd
that's
be
no good. That's
126 plus
And
130.
yes, the next week.
So it's gonna be 7 and 8.
Trying to figure out what.
You got it already.
It normally can't.
So it's.
You could do the worksheet either way, actually, because this is, how do I say this really? I could say .23, but more correctly would be 2,300. So